Okay, so let's walk through the technologies we've sort of talked about here. So this is our air conditioner. This is a window air conditioner. And typically a window air conditioner of this power is, yay big. It's the big boxes we're used to, and they're 80 or 100 pounds, even up to 120 pounds. And you lug them and put them in your window. So these are the air conditioners for poor people. These are air conditioners that are all over New York City. These are the type of air conditioners that are people's first air conditioner.
Okay.
So if you look at even the top medical centers in the world, from right up the street to the Chicago Medical Center, it's just filled with window air conditioners. And so we said, we're going to have to make these things automatically because the goal eventually is to change the weather.
Okay, so this is the external shell, and then
This is the shell, and these are the guts.
Okay.
And so this is what is inside of here. And so this is showing heating mode right now on the outside. And so you can see that designates the heat. And so these blades would be hot. This set of the heat exchanger would be hot. And it's hot because refrigerant flows through it. And there's a hub-mounted compressor that sits in the center right here. And so as the device rotates, it acts as a fan and a heat exchanger in one. And so we've developed, we call this the third fan. So maybe more fairly, we would call it the fourth fan. So the first fan ever was guy breaks a leaf off a tree and waves it on the cane. So the human powered fan. Then the second fan was they took those leaves and made them rotate around an axis. And that's an axial fan. That's a ceiling fan, same fans we use today, same fans that are propellers on our aircraft. The third type of fan is called a centrifugal fan, as we know, where as you rotate a stack of fan blades, these would typically be fan blades oriented vertically, you're taking in suction through the center and you're putting out pressurized discharge. This is very important because these are the same fans that are in our hair dryers, these are the same fans that are in our vacuum cleaners, and they're able to take suction through a filter. So they can have a negative pressure here, and then they're able to put pressurized discharge through ductwork.
Okay.
So in a nice house or a nice building, you're not starting out with high velocity air off of a propeller fan and putting it into the ductwork, because that would be very lossy, very inefficient. Instead, you're storing that energy as pressure. So all the ductworks in a building and in your house is pressurized. And then once it comes out of the grill, then it can turn its pressure energy into velocity energy. So this fan works in the same type of way, but it doesn't have any fan blades. The refrigerant tubes that flow through the center of the heat exchanger are sort of fan blades, but they're only aiding the dots that are embossed into our very thin heat exchanger plates.
Well, so you had said earlier that you were breaking the boundary layer, right?
We're able to shear the boundary layer in that we're dissociating the speed that air comes sucking through our air filter, which sits right up in this tray up here. There'll be an air filter that you will rinse every couple of days, and it'll be gross. And you'll rinse it in the sink and you'll think, boy, it sure is nice me and my kids aren't breathing that nasty air. And you'll stick it right back in there and it'll last for tens of years. And so the fan blades don't have to be held. And that's a big part of what we do here, is that when you have something like a fan blade, you then have to hold on to it with a larger thing. And that sort of hand that holds onto it is heavy and has to be manufactured and then has to be balanced. So we have ultra thin heat exchange plates, which allows us to emboss in them these golf ball sized dimples, which have been specially arranged to take suction and put out pressurized discharge with the amount of air that we need. So when we take a device like this and rotate it at a very manageable RPM of 2,000 RPMs, we're able to put out 400 cubic feet per minute of air, which is as much as, basically twice as much air as a typical giant box air compressor does, or heat.
The way that I would kind of view this is almost like, people might be familiar with centrifugal fan, this would be more like a centrifugal fan radiator, right?
Yeah, so we've combined the fan and the heat exchanger in one. So in testing, and this is where things get wild. So we've been able to test this fan right here. And it's very easy to test how much energy goes into it.
Yeah.
And it's very easy to test how much air comes out of it. And put that on the fan curve with a regular centrifugal blower. And when we take and compare it to the next most efficient centrifugal blower, this is twice as efficient.
Yeah.
Which, if you're an engineer, really blows your mind, because we're always told that centrifugal fans are something like 85, 88% efficient, yet they're noisy. So when this thing starts rotating, the plants on the other side of the room start moving, and it puts out massive air, and you cannot hear it.
Okay.
There's no sound. So, take that for what it will. It'll have to be tested by others. But like I said, it can take suction, put out pressurized discharge. So this is the third type of fan, or fourth type of fan, depending on.
Now, are you able to start this one up, or is this only a demo?
So this one is one that runs. And so one of the special things we're doing here with an air conditioner, and the reason we've been able to make an 8-pound air conditioner, which was typically an 80-pound air conditioner, so we're looking at 10x material savings, 10x weight savings, 6 times smaller, twice as quiet. We hope many times as efficient, but we're not quite there yet. And so what we're able to do, because we've hub mounted the compressor right in here, and I don't have one of those here in my home office, but you're able to spin the whole deal with, here we can open up the little other filter port and show you, but there's a brushless DC motor in there. And so brushless DC motors enjoy being modulated at high efficiency. And so that one, we only need one motor, and that runs this fan section, which would in a typical air conditioner be a different motor. It runs this fan section, and then it runs the compressor. They all work off that same motor. And so in a typical air conditioner, you can't modulate it down. You can modulate the fan down.
Oh, yeah,
but
yeah.
We're able to modulate the entire system down, which means because the motor sits in an air inlet, it means we're able to overdrive it to 130% for 3 minutes. So when you go in a Motel 6 and kick the door open and it's warm, and you want a lot more cooling out of the system, that's why they have a very big air conditioner in cheap hotel rooms, is because people want that cooling quickly. So we'll be able to overdrive for a few minutes and then step down and down and down. And the most comfortable cooling, which is what these are comfort systems, is supplied by operating these nearly full time. You want this thing running 50, 60, 70% of the time. It's smoothing out the air, and it's filtering the air, which is key. And then it's like, hey, this smells a little weird. Pop out your filter, go rinse it in the sink, a couple of drops of lemon oil, throw it back in, and you're right back in the races.
Yeah.
And so this is a higher quality air conditioner than the wealthiest people in the world enjoy. And we brought it down to the lowest price point. So this is going to cost us $100 to make. We hope to sell it on the shelf right next to regular air conditioners at around $400 or $500. We can sell these globally. They're assembled automatically like tin cans. So these are so thin that they will be cut on a paper cutter. So we're going to start with a massive mega roll, 40,000 pound, 4 foot wide, going 30 miles an hour through a $3 million paper cutter. It's going to emboss our bumps on it, and it's going to cut those out, shoot them into something that stacks them all, puts our very thin aluminum tubes through the heat exchangers, and now we've got a fan and a heat exchanger in one, which we will mate to what we call the core, which is our compressor and our motor, which will be tested and burned in, and so we know it's got the right performance. And once we mate those two together, this is going to be your future heater and air conditioner. And when you want to go, so this side's hot, this side's cold, when you want to go from heating to air conditioning, boop, that's all you do. And so the simplicity of the device is its key. And a typical air conditioner reroutes the refrigerant through a series of tubes to make the cold side hot and the hot side cold.
Yeah.
We just said, shoot, what about just doing that? And so even down to the paint, that blue color, designates it's an air conditioner. It looks cold, but that's stainless steel. And when you heat stainless steel up, we've all seen sort of a muffler on a motorcycle or something. That's all these rainbow colors. Every heat, a very specific temperature gives you a different color.
Okay.
And so this is, I forget off the top of my head, but this is a very specific temperature that creates this beautiful blue. But it also tempers the spring steel or the stainless steel into a spring. And so you have to be able to, we've all bounced a basketball off of our parents' air conditioner when we were kids, or written our name in a heat exchanger. And so this is a very thin casing that's rolled into its cylindrical form, and it has to be able to be kicked and bounced back. And so that blue color is not paint. That is an oxidation layer that corresponds with the temperature. And we put a flat clear coat on it to protect it, so it doesn't get smudged or anything like that. But that's the level of thought and level of detail we've gone into on the device. So you'll control the temperatures here, and you'll control the amount of airflow here, and then some combo of pushing the buttons to be able to change the time. And the little smiley face tells you when it's time to rinse your filter out.
Yeah, this is absolutely brilliant. You've completely rethought your conditions from the ground up. This is so exciting to see.
That's it.
Now, are you able to do a demo of it? Or?
No, I could spin this right now.
Okay, yeah.
Yeah, we don't have that.
Well, because I see it is disconnected from the cable.
Yeah, this goes in here. And our compressor, we're at the stage, we've done this in 10 years with only $3 million. Typically, people would have raised 10 times that, given the company away, and then who knows where it would have gone from them. So we still own almost the entirety of our company, which allows us to ensure that this will make it to market. Because if we would have teamed up with an incumbent, they'd say, oh, great, we'll take that. On the shelf it goes, because this is going to crash incumbent air conditioning. We hope. It was always my goal to make a 10 times better air conditioner, a solar powered air conditioner, and I think that's what we've done here.
Yeah, no, that's an amazing idea. I love the fact that it's like a centrifugal fan with air conditioner mixed together. That's absolutely brilliant.
Yeah, 2-in-1. So we've got twice the efficiency of airflow of a centrifugal fan, but what I didn't say is that's after transiting through a heat exchanger.
Okay.
Which is typically a very energy intensive process. And so it's but it's way above twice. And it's all, so this was all thought of and designed for manufacture. It's not, how can I do this at a $10,000 price point? It's how can I do this at a total cost of goods of $100, and how can we make tens of billions of these? So these will go in your electric vehicles. They'll work in heating and cooling. These will go in your homes. These will cool our food. These will cool our data in data centers.
Yeah.
So there is the ability to make a lot of these, and there's the need to make a lot of these.
Well, and that brings up a really important point too, right? We talk about EVs, you're talking about data centers. There are more cooling needs than ever before. And the technology for it, from what I've seen, hasn't really changed much in decades, right?
Decades. Or better, it's slow. The incumbents are making money with what they're doing. There is no incentive to do better.
Yeah.
And we've talked to them all, and they say, that ain't a money maker you're talking about for us. We're already making all the money we could possibly be making. And so the other thing that this challenge is, I don't know if you've ever had a trouble with your air conditioning system, but it's a get out the checkbook day. And if the guy says it's $5,700, you write the check.
Yeah.
Or if he says it's 12 grand, you write the check. Or maybe you get another quote, but that guy's 14 grand. I mean, it's very, the AC contractors really take advantage. And so this is a unit that you can order off Amazon. You could mail one to your grandmother. You could give to your daughter as a college present. And it's not like, oh gee, Dad, thanks for the air conditioner. It's like, oh cool, it's kind of like a PlayStation. So your daughter will have one of these. It'll follow her to college. It'll go in her first apartment. She'll take it with her. And then she can know that she's breathing fresh, clean air and doing so in a way that saves fuel. So those are the first two functions of this device. And as an engineer, it was up to me to say, well, what else can this device do? So like all air conditioners are actually triple function. So if you take the air conditioner out of your window, set it on your desk, close the window, turn it on, it will act as a dehumidifier. And if you come back in a little while, it'll be sitting in a pool of water. And all air conditioners do that. And ours is no different. And so just like if you have a cold beer, even in a dry area like Reno, even if you dry it off, after a couple minutes, you'll notice it's wet again. Well, that's condensing the atmospheric vapor down onto the bottle. And if you're thirsty, you could lick that bottle and you got some water. And so the problem with making water that way in an efficient manner, although it is done currently, you can buy atmospheric water generators. The problem with doing that is it makes the first little bit of water efficient. But just like our air conditioner rotates and shears off the boundary layer, those drops of water that it makes on the cold side, due to capillary action, they're held in between the heat exchange plates and they don't want to leave there. So it'll get wet, but it makes the first drops a lot more efficiently than the last drops. Because now not only do you have an air boundary layer, that air boundary layer is floating on that wet beer, that the surfaces themselves are wet. And so even though the heat exchange plate is cold, it has to make the water cold and then the air boundary layer cold before it can get to the air. And so that's extremely inefficient, and the efficiency goes down after the first few seconds of running it. Well, because we're rotating our device, we should be slinging water off of the device.
Yeah.
And so our next model, so this will be our first model, it's standalone, that's its own thing. We're gonna make another very similar model, different color. Hopefully we can use the thermal treatment to designate it as the water machine, maybe an aqua green or something like that. But that machine will sit right next to your coffee maker. And maybe you'll have a water tank down below. And you don't drink very much water during the day. And so the water you drink and the water you cook with should come from your air conditioner. And there's no reason that you can't have one of those in your car. Or if it hits the fan, you say, look, we're taking 2 air conditioners and we've got our electric vehicle, we're taking our water machine and we're beating it, or we're going to Burning Man, or we're going camping for the week. And so if you're washing the dog, use municipal water, or wash them in the river, washing your clothes, washing your car, those are your heavy water usages. But for that very little bit of water that we drink, and for that life support, these are life support systems that we make. So you have to have air conditioning or you will die sometimes in certain areas of the world when those areas are growing. Same with the heating. Have to have it or you'll die. Just like water. Have to have it or you'll die.
Yeah.
So great thing to take along in your electric vehicle. And then you can go set up a tent, and maybe you're not living great, but you've got water, you've got heating, you've got cooling, and you're doing it in a highly efficient manner to where you can battery power it and you can live. So that will be the third function of our device. And It's near identical to this, and there are ISO standards where maybe we'll do a UV filtration and yada, 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 make the water really clean. But all of the heavy lifting with that atmospheric water generation has already been done by the sun. So, some dog puked in a ditch 3 miles away and the sun hit that and you wouldn't drink that, but it boiled it up in a perfectly clean water vapor. Yeah, but then it kind of got mixed with some smog. So you've got this clean air, you've got this clean water, but it's smoggy. So you're gonna filter that air, filter the smog out through your filter, and then recondense that water. And then we'll have a couple post processes where we add some chemicals back into the water, so it's more easily digestible, some calcium or magnesium carbonates, and we'll do a UV treatment. And you will have anywhere in the world wireless water, battery powered water. So those 3 functions are inherent in the system.
Amazing, absolutely amazing.
Thank you. So we said, okay, let's push the limits on this. Is there a 4th function? And indeed there is. And so if you were able to focus heat energy on one side of the device, and this is already done, this isn't something I came up with, it's called the organic Rankine cycle. So you focus heat energy of any type on one side, you're gonna boil the refrigerant, and you're gonna spin the device backwards. And so the compressor you had for your air conditioner, you need that compressor still, and it'll act as a turbine to pull the energy out. Just like blowing into the exhaust pipe on a vehicle, you'll run the engine backwards. The engine thought it was made to go forwards, but indeed they all work just as good as a turbine, as a way to pull mechanical energy out of a pressurized fluid. And so we thought, well, what if we could put this as the focus of a parabolic dish? They already do that. That's a thing that is done. So you've got these giant paraboloids, and if you've got a paraboloid, the focal point of that is out here. And out here they hang an air conditioner, and they point it at the sun. And so we said, well, let's just do that. And then the old line got taken away, and we thought, well, who invented that the paraboloid? And it turns out it was Diocles in the year 220 BC. So this has been the way we've done it for quite a while. And although people have tried better methods, they've never come up with a better way of doing that. So currently, the most efficient collector are these paraboloids with a very heavy air conditioner hanging here. And it's also hanging, the target, the air conditioner, is in between the sun and the aperture. So it's casting a shadow on the aperture. And then also the whole thing is very non-aerodynamic. And so when wind's blowing on it, it gets these racking wind loads, just like a street light blowing in a big storm, it gets the frost built up on it. And those are the real design conditions on it. And so you end up having to have a very heavy base. You got just like a wind turbine, you got to dig it out and fill it with concrete and rebar. And you've got a moment load, so you've got the weight over here, and that weight is being held by the reflective dish itself. And so as the weight pulls down, it's bending the optic itself. And then you've got external lines of mechanical support. So it's like trying to hold the shape of a basketball through an outside support structure is not as efficient as if you're trying to hold it from the inside.
Yeah.
Because then those are internal lines of structural support, structural communication, and then they can lean on each other. And so we got to thinking, and we said, well, we need a new optic here. And so over the course of 5 years, and we'll be granted a patent on this next week, we've already got our patent number, we came up with Halo. So this is the hyperbolic astrolight optic. So hyperbolic is the shape of the main reflector. Astral light, starlight, our nearest star, the sun, is the light that it targets, and it's an optic, meaning it's engineered to optical grade. And so the interesting thing about this, unlike a paraboloid, to where if my wrist is holding my hand, the wrist takes a large torque and has to hold it there at all times. To where if you instead sort of put your finger inside of a cowboy hat, you can orient the hat in any direction and leave it there. And it's stable in all orientations without any holding force. Once you get the right point, if you have the tracker inside of the device. So that's stable in that orientation, and we can even get over to 90 degrees. And so from 7 or 8 a.m. when the sun rises till 7 or 8 p.m. when it sets, this halo device can track the sun across the sky. So the first time ever, this is much more efficient than a paraboloid. And the way it works is this is a reflective surface here, and there's also a reflective surface here on this halo. That's one of the reasons we call it halo. And so if you start at the center, this is 45 degrees to the incoming sunlight. So obviously 45 degrees is going to bounce light 90 degrees straight out to a portion of the halo that is itself perpendicular to the target, which is the air conditioner, which sits in the center and comes right back in and hits the target. And conversely, all the way out here towards the rim, this is approaching 0 degrees to the sunlight. So it's going to bounce it straight back up and hit the 45 degree portion of the halo, which bounces it straight back in. And it's 22.5 degrees in the center. And so very simple. And the tracker itself is ours and is protected. And so we have this sleeve and sleeve azimuth tracker. And there's also a crossbar here. That's a sleeve over a sleeve. And that tracks our elevation. And so we've had this operational for a year in a 6-foot form factor. And just this week, we made our first 6-foot wide main reflector. And in the next coming weeks, we're going to have our secondary formed. And so we'll be able to break the world record by a large margin in the ability to cheaply and easily and simply in a 6-foot form factor. I mean, that's the umbrella that goes over your picnic table. So you've got a couple of these, and I mean, you're talking 3,000 watts. That's big boy power. And so maybe we can convert half of that to power, but that's 1,500 watts in, this thing only costs us $100. And this thing only costs us hundreds of dollars, maybe $200, $300, $400, $500. Then there's the installation. But it's stable, and we've tested this through a year of computational fluid dynamics testing in all orientations and all wind angles. It doesn't matter which direction the wind is hitting it. It's always balanced. And so it doesn't result on a torque on the motors. So we can use very light motors, very simple motors, both in azimuth and elevation. And so like if it's looking right into the wind, the same force is here as is here. And so you don't have to have this giant apparatus, these big old forged gears that are in a typical parabolic collector, that those things tap out at 40 or 50 miles an hour. And they're aerodynamically unstable. And so they racked back and forth and couldn't track the sun. Where in a heck of a breeze, we'll be able to track the sunlight, maybe even on top of a car. We're not looking at doing that right now, but our whole system is made to pack up, put on top of your car, and get out of Dodge and be able to, off of your car, you could charge your car with this. 1,500 watts is a very meaningful amount of energy to put into your car over a day. And you can run your air conditioner, especially when your air conditioner is using on your juice. And then when a different version of your air conditioner is making your water. And so these are life support systems, and we hope everyone has one. So that's Halo, that's the reflector. Our target is a different version of our air conditioner. Our air conditioner is going to be entering the market in the next couple of years. It's in final testing, but as you can see, it's cheap, it's easy to make. That's that's kind of what we do here. And our goal, like we already talked about, is everyone needs one of these life support systems. I don't care if you're rich or poor or from Pakistan or Pennsylvania, you need air conditioning, you need heating, you need water, and you need some power so that you can charge your devices, you can run your air conditioner, you can run your water, you can put some in your car, your bike, and head down the street. And so once we have these basics, we already have the massive fusion reactor in the sky beaming us all this very valuable energy, then that could be the poison pill to disrupting the power structure that we currently live under. Whether you like it or not, we work for billionaires.
Yeah.
And so the way to stop working for billionaires and stop having your lifestyle enrich those types of people is through using these systems that allow us contact with nature, with the sun. So those are our inventions that we've come up with over the last 10 years. And in the future, we'll be announcing a very exciting partnership that we've recently landed with Halo. But generally speaking, if you're an American, you have invested in this. So I tell people this is your system. Thank you for believing in us. The National Science Foundation made this possible, and the greatest engineers in the world have looked at this and said, you've got something going here, and it's almost there. So, we're really excited to have made what we hope is the grandest impact that a technical device has made thus far, because the machines we use have changed the weather. So these machines have the potential to maybe change the weather back and just let us live. That's all there is to it. These are life support systems we all need.
Amazing. Thank you so much for walking us through this.
Thank you guys. Yeah, thanks for being interested in this.
Absolutely.
Yeah, but we really think this is the future.